Hi everyone, welcome back to this channel and I hope you guys are doing well. Today we are going to solve another LeetCode problem, that is contiguous subarray. In this problem we are given a binary array, then we have to return the maximum length of a contiguous subarray with an equal number of 0 and 1. For example, if our input array is this one, then one of the subarray would be this one where we have equal number of zeros and ones. Okay, so we need to find the length. So in this case it will be 4, and this is also could be, but we have the same length either way. So we only need to find the length. One of the most brute force way we can think of is, for each subarray we count number of ones and 0 and check if they are equal, while in the same time maintaining the length of the maximum subarray. But that is going to take order of n square, because an array of length n will have n square subarrays, so our overall complexity will be 1 order of n square. But with the given constraint, that is the length of the original array can go up to 10 to the power 5, so n square is definitely not going to work in this way. So let's see better approach for this problem. This problem is very similar to the problem where we have to find out whether a subarray exists in the array with a given sum. Okay, I guess probably you already solved that problem. In that problem, what we used to do, suppose we have an array and our current pointer is here, and sum till I we have this, let's say s2, that is prefix sum. 0 to I. Okay, and let's say this is our subarray with given target value. Then we need to check if this prefix subarray equals sum of that prefix subarray equals to s2 minus target. Okay, and let's call it s1. Okay, we need to check this one. Or in other words, we can say that if there is a prefix subarray with this sum s2 minus target exists in our array, then we can say that we definitely have a subarray with given target value. This is the technique we use to figure it out. Okay, and the same technique we can use with our current problem. But you might think that, hey, but we do not have target value in our case, but we can drive it. Let's see how. For this input array, our subarray will be with maximum length will be this one. Although there is other also exists, but let's take this one. Okay, so we have 1 0 1 0. Okay, as we already know that we have equal number of ones and zeros. So if we flip these zeros to -1, all the zeros to -1, then sum of our subarray will always be 0, no matter how long it is, because it has equal number of zeros and 1. Okay, so we have target values, so we can use the above technique to figure out. But previously we only cared about the prefix sums. Okay, but now we also have to take care of their indices. Why? Because we need to find the length of the subarray. There is a little trick while storing the indices of prefix sums. Let's see what it is. Since in our array we have both positive and negative numbers, so it is very highly likely that our prefix subarray sum could be same. Okay, for example, let's say this prefix subarray having sum s1 and the same for this one. They both have same prefix sum, but they are having different indices, and we need to store the minimum one so that we can get maximum length of our target subarray. Okay, let's take an example over here. So whenever we are in the first index, our prefix sum will be 1 and index will be 0. Let's quickly write those indices. So our prefix sum is 1 and index will be 0, and let's move it to next index. Prefix sum will be 2, index will be 1, and here, okay, prefix sum is 1. So we can check one is exist, yes. So what is the indices? It is 0. So at this point we can tell that we have a subarray with equal number of 1 and 0, that is current index 2 minus whatever we have, this value will be 0, that is 2. Okay, now since here also prefix sum will be 1 and index is 2, and we do not update here. Why? Because whenever we next time we encounter same prefix, here we will be encountering here, that is prefix sum is equal to 1. Now see, if we had updated that value with 2, then our desired subarray will have length 2, and if we didn't, then it will be 4. So of course the 4 is required for maximum length. That is why we do not update it. Let's quickly implement this approach and see it in action. So I'll declare the variable for s2 that initially will be 0, and our answer, that is length of maximum length of our subarray, it is will also be 0. And we also need a map to store prefix subarray sums and their indices. I'm only going to call it mp and then iterate over the array, and okay, so we also need to change that if nums I is equal to 0, then all we going to do is set it to -1. Okay, and then s2 plus equal to, and then we'll check if there exists s1. Now let me go back to that drawing. Here, since target is 0, so our s1 and s2 will be same in this case. Okay, so we can directly say that if it is exist, this key, that is s2, then our answer will be max of answer and or mp.s2. okay, and if we found, we do not update it, as we already discussed why. And if it does not exist, then we can say mp.s2 is equal to I. Okay, and that's all we need to do, and finally return our answer. Let's quickly run it. Okay, something is not right. Actually we need to add a base case over here to our this map, that is if sum is 0, then sorry, it should be -1, so that we can calculate length of it. Okay, so our sample test cases are run fine. Let's submit it. Okay, so it is accepted. Thank you guys for watching this video. Please like this video and subscribe to this channel.